Example 5.9. Dihydrogen monoxide is a liquid at room temperature and pressure. Well, this is water. I want to draw the Lewis electron dot diagram for this compound, and so what I need to do is I need to figure out the total number of valence electrons that are available for drawing the diagram. So, two hydrogens and one oxygen in the formula. Now what I'm going to do is I'm going to go to the periodic table, and you see that in the periodic table, hydrogen is in group 1A, oxygen is in group 6A. That means the hydrogen has one valence electron, the oxygen has 6 valence electrons. Let's go to the simplified periodic table and take a look at that. Well, here's hydrogen in the simplified periodic table, and here's oxygen. Remember, you just count the columns. So hydrogen's the first column, so it's got one valence electron. Oxygen is in the 6th column over, or group 6A. It has 6 valence electrons. So now I'm going to do my electron tally. So we have hydrogen, we have oxygen. Each hydrogen brings one valence electron. Each oxygen brings 6 valence electrons. Now, that means that when I go to find out the total number of valence electrons available, 2 hydrogens, so 2 times 1. And there's only one oxygen, so that's going to be 1 times 6. 2 times 1 is 2, 6, a total of 8 valence electrons are available. So now what I'm going to do is I'm going to put down the oxygen as the central element in this formula. Remember the rule I said, usually, almost always, the first element in the formula is going to be the central atom, unless the first element in your formula is hydrogen. So oxygen, I'm going to put as the central element, and what I'm going to do is I'm going to draw a single line representing the sharing of electrons, pair of electrons between the oxygen and the hydrogen. So this first bond, this chemical bond, which is the sharing of a pair of electrons, they're going to put 2 little red dots on there to indicate that that's a chemical bond where 2 electrons are being shared. And I'm going to do the same thing over here, the other bond. Now hydrogen does not obey the octet rule. Hydrogen is very happy with just 2 electrons. Call it the duet rule, if you like. The reason is hydrogen's single electron is in the first energy level, and that energy level is complete. There are 2 electrons in it. The next step in the process is I've got to distribute some more electrons here. Well, the oxygen does need to fulfill the octet rule, so it needs to have 8 electrons around it. So I'm going to do that. Well, how many does it see? Well, it sees 2, and 2 is 4. So the oxygen's just seeing 4 electrons, so I need to give it 4 more. I'm going to do that. Well, what do I have happening now? Well, the oxygen sees 8 electrons, and each hydrogen sees 2 electrons. So everybody's happy. How many electron dots do I have down there? 2, 4, 6, 8. I had 8 electrons to distribute, so I've got a happy Lewis electron dot diagram.